Determine if the following improper integral converges or diverges. If it converges, determine its value. So we got this fraction x1 over x minus 3 raised to 2/3, and we are working on the interval 1 through 5. So 1 through 5, so this closed interval. And if we look at closely at 1 minus 3, not a problem here. 1 minus 3 is -2, and 5 minus 3 is 2, not a problem. So what is the problem? 3 minus 3 is 0. Somewhere there is a 3. It's 1, 2, 3, 4, 5. In fact, there are infinitely many numbers. And at 3 minus 3 is 0. 0 raised to a number is also 0. And 1 over 0 is undefined. So here is a problem. So problem is at 3. Okay, and this 3 lies inside 1, 5. So we need to divide the whole domain 1 through 5 into two parts. 1 through 3 and 3 through 5, just to avoid that part. So we write in this way, 1, because 1 through 5 is without any work, we can clearly see 1 through 3 plus 3 through 5. Okay, now we got two improper integrals, by the way, because 1 through 3 minus 3 is 0. So problem here and problem here, but we can correct that using limits. So I'm gonna do 1 through, let's say, b. So 1 through 3 is here. I'm writing b, and b approaches to 3. Limit b approaches to 3. Now look at the direction, because we are going from left. It should be negative. This negative just for the direction. Later we don't care about this negative sign, just for the direction for now. 1 over x minus 3 2/3 plus 3 through 5. So we got 3 through 5, and the problem is at 3. So I'm going to replace this 3 by a and put the limit like this. Okay, so a through 5. So an a approaches to 3 from right side. Limit a approaches to 3 from right side plus 1 over x minus 3 raised to 2/3 and dx. So we need to evaluate two improper integrals here. Let's do it. These two integrals are the same. So instead of working with everything, let me just find the integral over here, just the antiderivative of this fraction, and just consider this without any limits. 1 over x minus 3 raised to 2/3 dx. Okay, how do we evaluate this integral? So obviously something is a composition, so u substitution. So let u be x minus 3, then du over dx is 1, and I'm writing in terms of differentials. So dx is du. So this integral becomes 1 over u raised to 2/3, and dx is just du. This one does not matter this time. So, and we know how to evaluate this. So 1 over u means u raised to move up negative 2/3 du. Now using the power rule, u raised to negative 2/3 plus 1, negative 2/3 plus 1, 1/3 divided by same thing plus c. I don't need, because we have to work on limits anyways. So 1/3 becomes just 3 u raised to 1/3, in fact cube root, and u is x minus 3. So this is 3x minus 3 raised to 1/3. Okay, so let's go up here and plug in those. So for the first one, we got limit b approaching to 3 from left, and this integral is here, 3x minus 3 raised to 1/3, and we are evaluating from 1 through b. So x equals 1 through b, plus same thing here, antiderivative of this fraction is here, 3x minus 3 raised to 1/3, and we have this limit. This is going from 1 through 5, and we have limit a going to 3 from right side. Okay, so we need to evaluate each integral. Okay, we have to evaluate, plug in x equals b, then x equals 1. Here x equals 5 and x equals a, and later replace a by 3, b by 3. This negative positive just for the direction. Okay, so let's do it. So I'm going to erase this because I need some room here. Limit b going to 3 from left, plug in b for x. So this 3 times, so we can pull 3 all the way outside. In fact, then we don't have to write twice. So this 3 is outside, nothing to do with this limit or these limits. So b minus 3 raised to 1/3 minus lower limit 1 minus 3, negative 2 raised to 1/3. Okay, that part, plus again this 3 can be pulled outside, limit a going to 3 from right side. Now plug in 5, 5 minus 3 is 2 raised to 1/3 minus lower limit, plug in a minus 3, a minus 3 raised to 1/3. So let me put bracket around just to see here. Now this 3 is outside. Let's replace b by 3. So b by 3, little bit less than 3. Anyways, this is close to 0 or 0. 0 raised to 1/3 is 0. This is 0 and there is no b. So we got 3 times negative outside, negative 2 raised to 1/3. Do not multiply negative and negative. Okay, because this negative has 1/3, this negative is just negative. It can be multiplied examining cases, but for now I would not. Plus 3 times, now replace a by 3, same thing here, 3 little bit more than 3, minus 3 is close to 0 but little bit more than 0, but in limit which is 0 raised to 1/3 is 0, so this is just 0, 2 raised to 1/3. Okay, this one. Now let me write this first. 3, don't multiply. Okay, 3, or we can factor 3 and 3 out from both. This one, I want to write this first. 2 raised to 1/3 minus negative 2 raised to 1/3. Let's simplify this if possible. Okay, I ask you not to multiply this directly, but let's look at 1/3 raised to 1/3 is pretty much cube root. So when we have cube root of negative 8, let me show you an example. That's negative 2. Okay, cube root of negative 8 is negative 2. This is same as negative cube root of 8. That's negative 2. So for cube root it works, but do not generalize this to like 4th root or 6th root or square root, because let's say 4th root of negative 8 is not same as negative 4th root of 8. In fact, not even positive, because 4th root of negative 8 is not a real number. Okay, these are hard to see, but not hard, but you have to think carefully. So, but for cube root or 5th root, it's kind of nice. So we don't have to, we can use this generalization. So we can simplify in this way. 2 1/3 cube root. This is same as putting negative outside, so negative, negative, positive. 2 1/3. 3, same thing. So this is pretty much cube root of 2, okay? 2 copies of cube root of 2. This one is cube root of 2 plus cube root of 2. When we add, we get 2 copies of cube root of 2. So 2 copies of cube root of 2. So 6, let me write cube root, or 2 raised to 1/3. So this is the final answer. The integral, the given integral converges to this number. The integral converges to this number.